Graham is the Director of Field Operations for Texas DOT Bridge Division. The Field Operations section oversees bridge construction support, maintenance, the statewide bridge inspection program, geotechnical design, and development of specification and standards. Graham's previous experience includes consultant structural design and forensic engineering services, as well as several years working in the TxDOT construction division, helping to oversee production of prefabricated bridge elements. He graduated in '99 with a BS in architectural engineering from the University of Texas at Austin. So please welcome Graham back up here.
So I can't remember exactly what the title is in the agenda, but really what I'm here to talk about is our move towards trying to beef up deteriorating bridge decks. And we've got a lot of those in the state. To talk philosophically for a moment, we had an interesting discussion during the new member lunch this morning, and somebody asked what's the difference, why do we differentiate between preservation and maintenance? And I thought that was a good question. I hadn't really thought about it before, but really I think that the difference is maintenance really gets into the nuts and bolts of what you're actually doing, and Tim did an outstanding job presenting on how you do that with the Hydro-Demo and the latex modified overlay. When you talk about preservation, I really think of it in terms of a philosophy and a strategy, really to oversee the asset management of all of our bridges. And in Texas, what I'm showing here is we've got our three categories, and these have all become very popular. Anybody paying attention to what the FHWA is espousing on bridge asset management, we know that there's a need for the routine and cyclic maintenance. There's a need for that middle category of repair and minor rehab, and then of course we all have to deal with the major rehab and replacement. And as a department, TxDOT has really focused on structurally deficient structures, and we've kind of been missing that middle category. And we've been very successful as we address SD, and in terms of on system, we're down below 2%, and I think pretty much every single one of our remaining SD bridges has already been programmed somehow for being addressed. So we've been very successful in terms of addressing those SD structures, but now it's time to kind of change philosophy. And while we remain SD will, of course, stay important, and those structures will continue to become SD, will remain a priority. But it's really time to start focusing more on that middle category and trying to help bridges keep from becoming SD in the first place. So this is something that, fortunately, we've had a lot of support from our administration on in the last few years. Before John Barton retired, he was very involved with this group. He earmarked a significant amount of money for us to be able to use specifically for keeping our good bridges in good condition. And we all know what happens if you miss that. It's pretty easy to maintain early on. If you don't do that, if you don't do a little more than just clearing the drains and cleaning the bridge deck every once in a while, then you're asking for trouble, and eventually your hand will be forced. And it's no fun having to deal with serious deterioration. Not a lot easier and a lot more economically responsible to hit these structures early on. So this is what we're trying to avoid. I'll show a few superstructure and substructure slides here. This is anybody here from Amarillo. I think they're sick of seeing their photos in my presentations. We're very fortunate in Texas not to have to use de-icing salts in many areas, but of course in those areas where we do, we get to deal with issues like this. Some more fun here, especially on that photo on the right there. That's a disturbing thing to go and find when you're looking at some steel piling. This is an interesting one that we're dealing with a lot. I'm not going to go too far into this because it's really kind of off topic, but this is a bridge squeeze, and this is a big one that we're trying to hit as far as that middle category. This is something that's pretty easy to handle as long as we catch it early, but if we let it go and don't do anything about it, all of a sudden our abutments are kissing our beams, and we're in big trouble. Now moving on to bridge decks, which is really what I'm here to talk about. We've got a lot of these. We've got a lot of bridges. Hala mentioned we've got over 53,000 bridges in Texas. We've got about 14,000 on-system bridges, 40% of the on-system inventory that was constructed between 1950 and 1970. I think that's pretty typical across the country, the interstate era. In that time, we've got a lot of variations in deck thickness, and also in reinforcing details. And what we're seeing now is a lot of significant deterioration in those decks, and there's a variety of reasons for that. a lot of times they're just old. They did their job. They were designed and constructed well, but these bridges were largely designed for 50-year service lives, and they've just kind of run out of gas, and so they're giving out. We do have corrosion problems, fortunately not as big as many other parts of the country, but of course that is an issue. And then reinforcement detailing. Some of our designers are really good at pinching pennies and trying to save every ounce of steel they can. And sometimes that's effective and sometimes it's not. So in terms of some of the deck deterioration that we see around the state, you can see the patches, we see punching failures. Obviously this is something that we are really seriously trying to avoid. They're dangerous, horribly disruptive when we have to suddenly close a bridge to traffic, especially in a metro area. I see a bunch of Dallas bridge engineers here. Unfortunately, this is a pretty regular reality for them. I mentioned a lot of our decks are just old. This was a very old one in about as far north Texas in the Panhandle as you can get. And a sheriff actually came up on a hole the size that he said you could have put a Volkswagen Bug through it if you wanted to. And you can see a creative use of some signs that were lying on the side of the road there, but whatever works. This is that same deck, and you'll see some more photos of this later on. I don't know how well that's showing up. But really, when you're looking at the underside of the deck and you start seeing this matte pattern cracking, that's kind of just the death knell of these things. It means that they're pretty much done, and I'll show you some more on that a little bit later. So I talked about the different deck thicknesses with different ages. We've used the much thicker decks now, but we've still got a lot of concrete decks out there that are 6 inches thick. They just give out. They do fine. The design was appropriate, but after decades and decades of use and lots of truck traffic, they just can't handle that load anymore, so they start to give out. And this is a 6-inch deck right here. Is that showing up, hopefully? Yeah, you can see that matte pattern cracking there. This is something that our group sees quite a bit of. And this is kind of the point where the question about how you rehab it becomes very easy, because it's pretty much replacement at this point. Now, in addition to the 6-inch, we've got a lot of 6.5 inch, a lot of 6 3/4 inch. Again, you can see some of the matte pattern cracking in the photo there on the bottom left for those thinner decks. We have a lot of pan girder structures out there. These things perform very, very well. The superstructures perform very well. The problem is the crowns of these things. Many of them are 3.5 inches. A lot of them are 4.5 inches. So it's kind of the same deal. The bridge performs well, but when you start putting wheel loads from trucks right over those crowns, then you can imagine 3.5 inches doesn't do real well. And this is the cracks there that you can see on the top left. This is very typical for pan girder bridges, but then you can see them start to worsen, like this one here. You see the efflorescence and some of the corrosion stains coming through there. And then the photo on the bottom left, here's one that is propagated all the way through to the top. This is no good. So what's our rehabilitation approach for bridge decks? We've got a lot of structures out there, even the older ones, even ones that were designed for 50-year service lives and are beyond that, where we have substructures and superstructures that are still performing very, very well, but the decks are kind of giving out. So in terms of this new maintenance program we've come up with a few different things that we really want to focus on. One of those is finding bridges that have those good, or I'll call it fair plus, superstructures and substructures, where we think that we can go spend some money on the deck and get another 20, 30 years out of these structures. You see that we've got some very serious surface area to talk about there. We've got 1 million square feet of deck that is rated 4 or less, and a full 15 million square feet that's rated right at 5. So it's not there yet, but it's close. So Kevin Pruski is our branch manager for construction and maintenance. He's really kind of steered the ship on this one, and he and I put together some plans for this, and we've got kind of a 10-year plan where we want to attack as much of these around the state as we can. And we've got 250 million kind of estimated right now, so some serious money to put into these decks, but we think it's well worth it. So how do we identify the bridge deck damage? Tim touched on a lot of these things. Of course, we've got the 2-year routine bridge inspections. These can be very effective from the bottom side. These kinds of cracks we see quite a bit of the time. We don't get too terribly concerned about them if we don't see anything besides this. But really starting to look more and more into the non-destructive evaluation. We're finding that it's getting more and more difficult and actually more and more irresponsible to be doing bridge inspections from the tops of decks as part of the routines, and we're really kind of moving away from that. We don't want to put people in the line of traffic, and we certainly can't afford to do traffic control for every routine bridge inspection we do. So we're trying to come up with other ways to evaluate damage, and the FHWA and the Long-Term Bridge Preservation Program have really made some great strides. I see Susan over there, so really appreciate the work they've done. We're trying some of those techniques. We do some sounding. We're really finding good success with ground penetrating radar. Unfortunately, we have some in-house resources in terms of that. We've done some impact echo, seen very good results out of that as well. And I know there's mixed feelings about it, but we've actually had some good luck too with the infrared thermal imaging. We've got a couple of really cool cameras, and we're able to take them out and identify delaminations that way. So Tim had mentioned the sounding. There's a good old chain drag on the left. I'll tell you, I know some people love it. I personally don't. I've never been a big fan of the chain drag, but that thing on the right there, I don't know if Brian Merrill made it or not. That's one of his toys, and when he retired, he took it with him. It was nothing but a brass ball that looked like a big bullet attached to a rope, and it was the best sounding equipment I've ever seen in my life. I loved it. It worked really, really well to identify hollow locations in decks. There's our GPR, and those are some of our in-house people doing it. We've done this at several large structures. This is very good for picking up, reinforcing the concrete cover. And you have to really know what you're looking at there. I put this slide up just to kind of show you what they're looking at. Sort of makes sense, but I think it makes a lot more sense to people who actually are involved in this. And in the last photo, so this is the GPR, and there's Kevin on the bottom right doing some backup checks with the rebar locator, and that's what we plotted here. The blue is the rebar locator, and the red is the GPR. So a few irregularities, but overall the GPR seems to be doing a really nice job of telling us where the steel is. Impact echo, this is really cool, and what we're looking for here is delaminations, and this was awesome. This worked really, really well at some large direct connects up in East Texas, and really a little easier to follow here. And I know you probably can't see it, but blue is good. Blue means it went all the way through the deck, nothing bounced back. And then you see these other areas, red and yellow. These are areas where it is finding that defect. And I know impact echo can also be used to find defects in concrete. Really what we were using it for in this case was to see if we had large-scale delaminations, because we suspected that we did, and sure enough, this confirmed. Infrared thermal imaging I mentioned. So this is a series of bridges in downtown Waco where they have had a lot of very serious punching failures, dangerous punching failures, hugely disruptive to traffic when they have to shut down Interstate 35 unexpectedly. And so after we had done our assessment, we followed it up with some infrared thermal imaging from the bottom, and really ended up finding so many anomalies that we ended up just, instead of trying to, our hope was we'd be able to find the isolated defects and address those, and we ended up just saying, no, this is a systemic problem and we need to do the whole thing. The reason I showed this photo, I will say that I was a bit skeptical when it came to the thermal imaging, but this is the one that really changed my mind. This is a CAP out in West Texas, and I was out there to look at something else, and had just taken the camera at my former boss Keith Ramsey's insistence. I don't know if he's here or not, but he was just determined that we use these cameras, and I took it out there just to kind of play with, and sure enough found what appeared to be a large delamination that was in no way visible from the ground. And I got a ladder and a hammer, went up there, and sure enough, and knocked it right off. So I think it can be very effective if used properly. And it doesn't take, you have to know what you're doing, but really it doesn't take that much expertise to be able to use one of those cameras, and we are finding now that they are effective. I'll plug for the FHWA long-term bridge preservation program here. They've done really a nice job with their website. They've got several excellent tools out there in terms of non-destructive evaluation. All you need to do is just Google FHWA LTBP. So I'm very appreciative of the efforts there, and we're really following along to see what opportunities they have. In particular, they've got a tool where you can go in and tell which part of the bridge you're looking at, what the defect is, and it'll really just kind of walk you through step by step which non-destructive evaluation tool you should be using, and then a description on how that tool works. Continuing along those lines, this is something that is under development. This is what FHWA is calling the Rabbit Bridge Deck Assessment Tool. This was done by Rutgers, right? And so far just in New Jersey, so we don't have an opportunity to use it yet. My hope is that we will. Yes?
We are using it with some states. In fact, next week it'll be in California for the Oakland Bay Bridge, one of the tunnels.
Fantastic. That's very good to hear. What's that? When can it come here, Dick says. I like that question. So all these things that I've been talking about, it's kind of all wrapped up in this one. It's got the panoramic cameras, does the high definition imaging, really the impact echo, and GPR. That seems to be where a lot of people are heading. This does both of those things in addition to some other items. So hopefully this is something that takes off and we're able to use. Okay, so let's talk degrees of damage. When we look at these things, obviously we have non-structural issues and structural issues. So non-structural, isolated cracking. A lot of times we have the widespread cracking, and then on some of our older bridges where the concrete the bridge deck was designed well, it's just been worn down. So we have uniform wearing on those. Structural, now we're talking some serious rehabilitation or replacement. So in terms of what we do with these non-structural items, really determine what we need to do as far as taking care of these cracks. The low viscosity gravity fed epoxy is what we're using. TxDOT maintains a list of pre-approved manufacturers and specific materials. We've got a big group from our construction materials lab here. They do an excellent job of making sure that only good materials end up on that list. So it becomes a very good tool for our contractors to use, and very effective for us as the owner to make sure that only good material ends up on our bridges. So the discrete crack sealing works great. Unfortunately, it's extremely time-consuming and expensive to try to do that. If we have isolated cracking, certainly this is something we'll pursue. And in the past, I've been a fan of building the little dams on each side of the cracks and trying to build up the pressure head. Kevin has said he's seen less success out of that than just multiple brush applications. So that's kind of the direction we've gone, as opposed to trying to build up that pressure head, just taking a brush and going over several times right over the crack, and that seems to work very, very well. Unfortunately, again, like I said, very time-consuming and very expensive to take that approach. Now, if we have widespread cracking, we found that this gravity-fed low viscosity epoxy works really well, typically with a squeegee or wet nap roller. Add a coarse sand just as a friction element for the traffic. Now the problem is we groove a lot of our bridge decks, and this low viscosity epoxy works so well that that can become problematic when you're trying to squeegee on a groove deck. So if you have the right material and the right contractor, then this can be a very effective means to fill cracks. All right, so here's what I was talking about with uniform wearing, and I went over this presentation with Kevin a couple of days ago, and he was surprised I was showing this photo because it looks terrible from the top. But I'll show you a photo on the next slide on what it looks from the bottom, and it actually has held up very well. This is a 1930s era bridge, and the bridge deck is really just performing beautifully despite what this photo looks like. But this is an area where we would start looking at something like a multi-layer polymer overlay, where structurally it's fine, but we've started to see some reduction in the clear cover for the steel, and we're going to start to see some corrosion problems and other things if we don't do something about it from a waterproofing standpoint. The multi-layer polymers, typically we're going for a total of about 3/8 inches. I think that's pretty typical around the country, but you've got your crack sealant that goes in first, and then you've got your aggregate and your resin. Once again, we have a list of pre-approved suppliers and materials for that. What our spec list is, this could be epoxy, modified epoxy. We use a lot of methacrylate and have seen very good success with that, and there's other polymers out there that work as well. So this is that same bridge deck from the bottom side, and I don't know how well you can tell there, but from the top you would think this thing was falling apart, but you go and look on the bottom side and really performing very, very well. But here's what I was talking about. You can see the uniform wearing, and sure enough, reinforcement starts to become exposed in a few locations. This is an interesting application just a couple weeks ago, and I hadn't seen this one, but we got a concerned phone call, rightly so, from a citizen saying that reinforcing was popping up as she was driving over it, and some of this reinforcement had become dislodged. And so our solution was to just do discrete applications of polymer just to hold the steel down temporarily, and we'll go back in with an overlay a little bit later. Certainly this isn't something we're doing on a widespread basis, but I thought it was interesting enough to include here. All right, so let's get into the real meat of this thing, beefing up bridge decks. So now we're into the territory where we're talking structural. We've gone beyond waterproofing. We've got a problem with our decks that we need to address from a structural performance standpoint. Our specification includes two options. We've got a CO mix, that's just bridge deck concrete overlay, and it's very similar to our regular concrete mixes. It's got a little bit higher strength, smaller coarse aggregate, but there's really nothing magic about it. It's the same typical recipe that you would use for any structural class of concrete. And then of course there's what Tim was talking about, the latex modified concrete overlay. We've used it some, we haven't used it a whole lot. This is something that we're excited about and kind of earmarked as an opportunity moving forward to use probably a lot more of. Tim also mentioned the 1.25 inch minimum thickness. We really try for 2 inches if we can get it. We know that the latex helps it bond. I think we've just been burned so many times on different kinds of concretes and mortars and everything else delaminating without a mechanical bond that inch and a quarter makes us nervous. Maybe the more we use the latex, we'll get comfortable with the thinner applications. But without that mechanical tie, really we're trying for 2 inches for now if we can get it. We'll see if our philosophy changes on that. Surface prep, so we like the roughened surface to promote mechanical bond. The Hydro-Demolition is excellent for that. There are some times when the cost just isn't justified, so it becomes much more difficult to get that roughened surface with shot blasting or other techniques, but it can be done. And really, the clean, saturated surface dry is just absolutely critical. We can't emphasize that enough. Everybody who's ever heard me present on anything hears me say that. It could be not related to concrete, and I'll manage to get clean, saturated surface dry in there somewhere. We don't use grouts, we don't use bonding agents, anything else. Just there's nothing more effective than clean, saturated surface dry to get the concrete to bond properly. So I mentioned the concrete overlay mix. I say low water to cement ratio. I think the spec says 0.40, which really isn't even that low. Smaller coarse aggregate, I think it's 3/8 inch max. We see that it works particularly well in thick applications, and what I'm trying to say there is that we recognize the benefits of latex modified. It is expensive, and so we'll use it when it's justified. But if we're having to go so deep that we're going beyond 100% the level of reinforcement, we find that this concrete overlay mix works really well as long as it's got that reinforcing cage to tie it down. Latex modified. Did a very good job in the presentation before mine, so I won't spend too much time on this, but the very low permeability obviously is a plus. Lower modulus elasticity than plain concrete. That's a big plus, and I think this is a very common misnomer that, especially with repair material, high strength is a good thing. Well, high strength almost always means high modulus of elasticity too, and high modulus of elasticity can be very problematic for repair material because as the parent material tries to bend, that repair material doesn't want to bend with it, and creates a lot of problems. So the lower modulus is good. I say less stringent curing. I'm not trying to say that the curing is not important. I guess when I say less stringent, less time than standard concrete. And a lot of times a latex modified overlay is being used when you need a fast return to traffic. So whereas we require multiple days, many days of curing on standard concrete, Tim, what do you require? What is the minimum on the latex
For minimum.
in your spec?
I'm sorry, for
There's two different
oh, is that
specs.
yeah, we have two different specs. We have just our regular spec, which is 7 days strength, but our overnight is 3 hours.
Okay. So the curing remains critically important in both, but you don't have to do the latex for as long. Okay, so getting into the process here. A lot of our bridges have asphalt on them, and so if there's asphalt, obviously the first step is going to be milling that off, and we're very careful to require a separate milling operation for that. We don't want to require the milling of the asphalt and the concrete in the same step because of the danger that Tim addressed. You don't want to accidentally go too deep. You don't want to start getting into that reinforcing steel. So step one is milling the asphalt off. Step two is the second milling operation. That's for the concrete, and you have a very specific depth that you're able to mill down to. This is much less expensive than the other preparation techniques, so we want to use as much of that as possible. So there, those bottom two bullets, shot blasting and hydro-demolition, really it's going to be one or the other of those. So shot blasting can be effective, not as effective as the hydro-demo, but far, far, far less expensive, and depending on the application, it can be perfectly effective. Important that the remaining concrete be sound. Hydro-demolition, highly effective. This is something that we haven't used a whole lot of yet. Contractors have opted to use it on their own a few times. We're about to start our first really, really large-scale hydro-demolition plus latex modified overlay project in Waco. When I agreed to do this presentation last year, I was positive that was going to be underway, and I would have photos of it. And sure enough, we move at the speed of government sometimes, and the project hasn't started, but one of my very good industry partners was kind enough to share some photos, which I'll show you in just a minute here. Tim mentioned it. I'll second it. That one of the things we really like about the hydro-demolition is that it locates unsound concrete. Very important on some of these older bridge decks where we really don't know, and the last thing we want to do is remove to a specified level of concrete and then find out too late that we had some punky stuff underneath that we ended up trying to adhere to, because that's a recipe for short service life. The bridge that I'll show you, the bridge that we're actually working on, this is it. This is the structure where we're doing the hydro-demolition. I don't think we're going to go through the deck, but I was very, very careful in specifications to say that nobody could be walking or driving underneath the deck during the hydro-demolition operations, because I suspect we may punch all the way through in at least a few spots. Okay, so thank you again, Mr. Liberati, if he's here. He was kind enough to share some photos of this, and this is very similar to the operation that we'll be carrying out in Waco. And you can see, of course, this has obviously had a series of punching failures and patches. So this deck is a goner. So here's a milling operation. It is what it is. Fast, effective, inexpensive. So you want to do as much of the milling as you can, as long as you're very careful to stay away from the reinforcing layer and you're not damaging anything that's going to be left in place. So here's what you got after the milling. So this is the hydro-demolition operation. There's a lot of the chunks of the concrete around it hasn't been cleaned up or vacuumed yet. I was surprised the first time I saw this. Everything I'd heard about hydro-demolition, I was expecting this just gigantic piece of equipment. It's really not the case. It's the truck supporting it is big, but the actual hydro-demolition equipment is quite small, and it's a cool thing to watch. So this was a test area that they had done. You can see the nice roughened surface there, and deeper in some areas. So again, very good at going to the specified depth, but locating any of the unsound concrete. It's a little further down. So here's your big vacuum cleaner going up over the top of it, getting rid of all the loose stuff. And you're done with your preparation. Nice, very nice, rough surface. That's a beautiful thing for bonding to. And looks just like a bridge deck placement, doesn't it? Here's your latex modified overlay going down. And that's what it looks like when you're done. So this is something that I think as a department we'll be doing a lot more of. We really see the benefits in both the concrete overlays and in the latex modified overlays. Okay, so then we start weighing sometimes again, bridge deck rehab versus replacement. Sometimes we find a deck that really should be replaced, but that becomes problematic in either metro areas where closing a bridge it creates a major traffic disruption, or even more often in the rural areas where a detour may be many tens of miles long, and it's just not realistic to close a bridge down. Another problem you can see here is really phasing isn't even an option. You've got two girders here, no way to phase that. We haven't tried to do the whole, balance wheels on both sides of the girder thing. And then even here with a 4-girder system, you'd think you could find a way, but really when you start looking at it, to try to do a phased construction over one of these first interior girder lines, there's just not enough room to squeeze a car in here. So sometimes our hand is forced a bit, and we do structural overlays, even when we would prefer to do a deck replacement. So here's some of the map cracking that I was talking about early on. Doesn't take much evaluation on this. This is just kind of the telltale sign for us. Once you start seeing these, efflorescence is one thing, but when you start seeing this pattern of cracks underneath, it's just kind of given out. The deck is just kind of done. And we see this on a lot of the older, thin 6.5 inch decks. So those are the ones where we start talking about bridge deck replacement as opposed to trying to beef them up. Lots of advantages in the bridge deck replacement aspect. Even I mentioned that we're trying to identify substructures and superstructures that are in good shape. Even in those that are in good shape, you still see a lot of issues like this where the water has been seeping in and you're starting to get some corrosion. If you try to just recoat this, it's really difficult to get into some of those hard to reach areas, and after you're done, the corrosion can continue. Very nice to just rip that sucker off, and you've got great access to all the superstructure. You can blast it, recoat it while you're there to redeck it. Also, really good opportunity to up the capacity of bridges. A lot of our older steel structures were not made composite with the decks, and so this is a very common thing for us to go in and add some Nelson studs and significantly increase the capacity of the structure by making the deck composite. And there you go, just like a normal new bridge. Put your reinforcement in and cast your concrete. So I really hesitated on whether or not to put this slide in. I know it'll get some dander up. I really want to emphasize that a lot of these things are fairly new to us, and rehabilitation costs really we find vary so much from bridge to bridge and location to location that it's hard for us to even come up with unit rates for this kind of work. Really what I was trying to highlight was we're well aware that some of these things work very, very well, but you do have to take into account the additional cost sometimes. So we do weigh the cost of the rehab. Now we also look at the overall cost of a project, and if we're spending $2 million on traffic control, then trying to save $100,000 in materials doesn't make a lot of sense. So in those cases, we'll go ahead and be willing to spend more money. But on some projects, it is important to really evaluate and try to be good stewards of the taxpayers' money and not necessarily always do the absolute best thing, just do what's good enough. So you can see there the difference between the shot blasting and the hydro. Hydro, we've only done very, very, very few of these, but shot blasting, very inexpensive. Hydro-Demolition, far more effective, but way, way, way more expensive. Overlays, the multi-layer polymers, we see 30, 40 yards, $30, $40 per square yard type territory. 2-inch concrete overlay, 60 to 80 bucks, and then you can see a similar 1.5 to 3-inch latex modified. Right now, at least for us, we're in the neighborhood of twice as expensive. Our hope is that as we do more hydro-demolition and latex modified overlay, because we haven't done much of it, there's not much of a presence for the suppliers or for the contractors. So we're very optimistic that these prices will come down, but for now, these projects are really, really expensive for us. To compare, a bridge deck replacement is somewhere in the neighborhood of $250 to $300 a square yard. So this is something I try to emphasize a lot. Really, our primary plan for maintaining bridges is to design and build them as maintenance-free as possible, and that goes for bridge decks as well. We use high-quality concrete. I don't say high-performance concrete. We do certainly have an HPC requirement in our spec. Fortunately for us, well, fortunately or unfortunately, we've got a lot of coal plants in Texas, and so that means we've got a lot of fly ash in Texas. So our contractors put fly ash in our concrete whether we ask them to or not, which is great. So we end up getting HPC, because the fly ash is less expensive than cement, we end up with high-performance concrete, and we pay for standard concrete. It's a great thing. We've gone to thicker decks. We're going with 8.5-inch decks all over the place. Not only does that increase the cover for the top mat of steel, it just kind of beefs it up. And avoids this problem that I showed with these 6 and 6.5-inch decks. We've got a lot of hot and cold weather provisions in there. Some very stringent curing requirements, and something that we just added to this recent spec rewrite. We made the contractor responsible for addressing cracks and doing repairs, and so we didn't go performance-based on many things, but this was an area where we really saw an opportunity to build in an incentive for the contractors to want to do it right in the first place, because the last thing we want is a brand new deck, and I know the feds hate brand new bridge decks with cracks on it. So this is something that we're hoping will be real effective. Just a few more slides here. We've got a lot of our district colleagues here. Something that we've really pushed lately is really trying to not put asphalt on our bridge decks. And it's something that's been done all over the state for a long, long time, and that creates litany of problems. Obviously, you reduce your capacity because you're just putting dead load on there. We find that the asphalt holds moisture and other contaminants against the concrete, reduces rail height, and creates debris on caps. And I've got just a few photos. This is an extreme example. This is in Texas. I will say this is the only case of this that I know of. If you can't read that on the bottom right, that is 11 inches of asphalt on a 27-inch rail. So, not typical. But I will say this one is pretty typical. It's not unusual at all for us to see 3 to 5, 6 inches of asphalt on bridge decks. We don't want that. You can imagine that it really affects where a vehicle strikes a rail, so the rail doesn't behave like it was designed to behave. And here's one. The asphalt doesn't all stay on top. It makes its way through our joints and does all kinds of gnarly things to our bearings. And we have seen some pretty serious problems, especially with these rockers that no longer rock when they get surrounded by the asphalt. Did I do it in 25?
Yeah, close enough.
All right, good. Do we have time for questions?
I think we probably have time for 1 or 2 questions.
1 or 2 questions?
For the latex modified treatment, what are you used, or what is done to keep that? It looks like it'd be really slick. Is there something done, or is it not slick, like the surface? You did the whole surface. Is it not slick?
No, it's not slick.
Okay.
And I'm glad Dan's here because he can correct me as soon as I say something that's wrong. What makes the latex modified different from the regular concrete overlay is you're replacing about half the mixed water with the latex, right? So in terms of of the surface and everything, it's not effective. It's just like a regular concrete.
Okay.
One more question, anybody?
I saw some stay-in-place forms. Are you using those on a regular basis?
Oh, absolutely. On our decks?
Yeah.
Yes. Yeah, almost entirely. We don't require it, but we just changed our standard. It used to be we showed the full depth cast in place and allowed the stay in place. We just switched that because everybody was doing the stay in place concrete, the 4-inch precast concrete panels anyway. We've had very good success with them. I know that there's differing opinions around the country, but in Texas, we're almost exclusively PCP.
And I'm going to use my prerogative as moderator to ask you a follow-up question.
Okay.
On your rehab work, you showed square foot, I believe, of 4s and 5s. Are you trying to get those back into a fair or good condition?
Excellent question. So we're trying to get, as part of that, what I call the middle territory. So we're not at major rehab or replacement yet, and we're beyond cyclic maintenance. We are definitely trying to get everything pulled back up to a 7. We want the bridge to be in good condition, every element to be in good condition by the time we're done. And so we're there typically to address one major thing. We're there for one reason, but we're also very careful to go and evaluate the entire structure because we want to find everything that's wrong and hit it all while we're there, and so we can then walk away from that bridge for 25 years.
Excellent. Thank you. How about a round for everybody?